Any linear system of two equations can be solved by graphing, substitution, or elimination. All three methods will give the same result. So example 5. Consider the linear system y equaling 2x plus 1 and y equaling 2x plus 3. So I can solve the system by any method of my choice. The way it's set up with y equaling 2x plus 1 and y equaling 2x plus 3, the fact that the y's are isolated makes this easier to solve by substitution. So I will take my first equation, the 2x plus 1, and substitute it in for the y in the second equation. So that will leave me with 2x plus 1 equaling 2x plus 3, because all I'm doing is taking the 2x plus 1 and plugging it in for the y. So to solve this, I would subtract 2x from both sides, and this would leave me with 1 is equal to 3, since 2x minus 2x is 0, and 2x minus 2x is 0. So I'm left with 1 equaling 3, which is not a true statement. So what this means is that I have an inconsistent system. So if the result of applying substitution or elimination to a linear system of two equations is a false statement like we had, the system is inconsistent. That is, the solution is the empty set. In this case, if I were to graph it, these two equations are parallel. They have the same slope. So if I were to graph these, a rough sketch of this would look something like this. So since solving a system of linear equations is looking for where two lines intersect, and if our system is parallel lines, it means they never intersect. So a system that contains parallel lines is inconsistent. It has no solution, and it will yield a false statement in the end. Now consider example 6, where I want to solve the system y equaling 2x plus 1 and 6x minus 3y equaling negative 3. This is another system that's good to solve by substitution, since one of my equations is already solved for one variable. So I'm going to take the 2x plus 1 and plug it in for the y. So I get 6x minus 3 times 2x plus 1 is equal to negative 3. So this gives me 6x minus 6x minus 3 is equal to negative 3. 6x minus 6x cancels out, so I'm left with negative 3 is equal to negative 3. So in this case, I'm left with a true statement. So since negative 3 equaling negative 3 is a true statement of the form A equaling A, we conclude that the system is dependent, and that the solution set of the system is the set of ordered pairs represented by the points on the line y equaling 2x plus 1. So in other words, if I were to graph these two lines, they would end up being exactly the same line. They just look a little different. So these two are the same line. I ended up with a true statement, which means the system is dependent. So there's an infinite number of solutions.